All right, let's dive right in. We're going to talk about something that's, believe it or not, over 50 years old, but it's probably the most important piece of software you've used today. We're talking about the blueprint for our entire digital world, an operating system called Unix. So let me ask you something. That phone in your hand or the laptop you're on, the servers that are beaming this to you right now, what if I told you the core ideas powering all of it were born way back in 1969? Yeah, 1969. It sounds kind of crazy, right? But it's totally true. And the answer, as you might have guessed, is Unix. Okay, before we go any deeper, let's just make sure we're on the same page. What even is an operating system, an OS? Well, think of it like the conductor of an orchestra. It's the foundational software that tells all the hardware, the processor, the memory, everything, what to do. It's the bridge that lets you, the user, actually talk to the machine and run all your apps. All right, so let's get into the story. To really get why Unix is such a big deal, we've got to rewind. Let's go all the way back to the beginning to see how this one idea completely changed the game. So picture this. It's 1969. We're at AT&T's Bell Labs, which was basically the Silicon Valley of its day. I mean, just a powerhouse of innovation. And you've got this small team, guys like Ken Thompson and Dennis Ritchie, and they just wanted to build an operating system that, well, that didn't suck. They weren't trying to change the world or make $1 billion. They were just trying to build a tool that they actually wanted to use. And what they came up with was Unix. Now, we got to put ourselves back in that time to understand how wild this was. Multi-user, that meant more than one person could use the same expensive computer at the same time. Multitasking, it could juggle multiple programs at once. But the real kicker was portable. The idea that you could take the OS and run it on different kinds of computers, that was a complete game changer. Nobody was really doing that. But here's the thing. The secret sauce of Unix isn't just the code itself. No, it's incredible staying power. The reason we're still talking about it today comes down to a really simple but powerful philosophy that was baked in from day one. And it all boils down to this one simple sentence. Instead of building one giant, complicated program that tries to do everything, like a clunky Swiss Army knife with a million attachments you never use, the Unix approach was totally different. It was about creating lots of small, sharp, individual tools. A perfect little hammer, a perfect little screwdriver. Each tool does just one thing, but it does that one thing incredibly well. So how does that actually work? Well, it's a three-step dance. First, you write those small, simple programs. Second, and this is where the magic really happens, you connect them. You take the result from one tool and feed it directly into the next one. It's like a digital assembly line. And by snapping these simple tools together, you can build incredibly powerful and complex solutions. And third, the secret ingredient, everything is just plain text. This makes it a universal language that every single tool can speak. Genius, right? Okay, so that's the philosophy, but how do you actually build a system like that? Well, this wasn't just some vague mission statement. This whole idea was built right into the core architecture of Unix, creating a super clean, modular design that people still study and admire today. The easiest way to picture the Unix architecture is to think of an onion. Seriously, you've got these layers. Right at the very core, you have the hardware. On top of that is the kernel. That's the real heart of the system. The next layer out is the shell, which is your way of talking to the kernel. And then on the outside, you have all your applications and all those little utility programs we were just talking about. Each layer has its own job, and they all fit together perfectly. So let's zero in on that center layer, the kernel. The kernel is, for all intents and purposes, the boss. It is the ultimate manager. It controls everything. It decides which program gets to use the CPU, how the memory is shared, and how to communicate with every single piece of hardware plugged in. You can think of it as the brain or the central nervous system of the whole machine. Okay, so if the kernel is the all-powerful brain, how do you, the user, actually give it orders? Well, that's where the shell comes in. The shell is your direct line to the kernel. It's that command line interface, the blinking cursor on a black screen where you type in commands. And this is the critical part. The shell is the playground where you can string all those little tools together and make that Unix philosophy come to life. All right, we've looked at the why and the how, the philosophy and the architecture. Now for the really cool part. Let's zoom out and see how this thing escaped Bell Labs and literally took over the world, to the point where its DNA is probably sitting in your pocket right now. Just look at this family tree. It's pretty amazing. Fast forward to 1991, this college kid, Linus Torvalds, creates a Unix-like kernel and calls it Linux. Then, in 2001, Apple makes a huge move and rebuilds its entire operating system, what we now call macOS, on an actual certified Unix core. And then, in 2008, boom, Android comes out, and what's it built on? The Linux kernel. You can draw a straight line from that lab in '69 to almost every device we use today. Now, this is something that trips a lot of people up, so let's clear it up right now. Unix versus Linux. What's the deal? Here's the easiest way to think about it. Unix is the original recipe, the blueprint, the set of brilliant ideas. Linux is like the most famous, most successful open source version of that recipe that someone cooked up from scratch. It's Unix-like, but it's not the original AT&T Unix. It follows the same philosophy, but it's its own thing. So where is this Unix DNA today? Honestly, it's easier to ask where it isn't. It's the absolute backbone of the internet. The cloud servers, the web servers, you name it. It runs the massive, critical systems for banks and telecom companies. It's inside every single Mac computer. It's on billions of Android phones. It's in your smart TV, your router. It is the invisible, foundational layer of the modern world, period. So if you take away just one thing from all this, let it be this. The legacy of Unix isn't really about some lines of code written 50 years ago. It's about a revolutionary way of thinking. It's a set of simple, powerful ideas that turned out to be so good, so right, that they're still the gold standard today. And that kind of leaves us with a really big question to chew on, doesn't it? As our world gets more and more complex, we're talking AI, quantum computing, things we can barely imagine. Is this 50-year-old philosophy of keeping things simple, of doing one thing and doing it well, is that still the best way forward? Is it the foundation for the next 50 years? It's something to think about.